So welcome to the now slightly emptier room. I hope you still have a good time and enjoy my talk. And I'm going to talk about Zen Framework and Symfony 2. But I want to make one thing very clear from the upstart. This is not going to be a Zen bashing session. There's reasons why we moved from Zen Framework to Symfony and why we love Symfony. But I want to talk more about the positives, I guess, then, of Symfony and kind of just the drawbacks we saw with Zen Framework 1. You also have to keep in mind this is Zen Framework 1 and not the new Zen Framework 2, which just came out. So I'm talking about the company that I actually work at, so that you have some appreciation for the scale we're dealing with. And touching briefly about HAL, because that's a big part of what we're dealing with. And then kind of go through an example of before switching to Symfony and after, to kind of make a point of why we enjoy switching to Symfony so much. And then talk a little bit about kind of, the lessons learned and kind of what we found out from it. So who is this guy standing up here? Some of you may have not seen me ever before because I'm not super active like some other people, but I am contributing on GitHub. You can find me on Twitter. If you want to bash the talk right now, this is the handle to CC. And I'm an architect at a company called Outlook, which has a kind of weird name. And whenever I say that, people are always like, oh, so you work for Microsoft? No. Not Outlook, Outlook. It's an American company, so it's not the French pronunciation that many people really want to do. In fact, when you get hired, there is a sheet of paper that you get from HR that basically explains to you how to pronounce the company and how not to. So what is Outlook? Outlook is a flash sale site, as they're called. It's a members-only shopping site. And they basically do private, limited sales events. So basically you have brands, say Tommy Hilfiger, and they want to sell out some inventory. So they basically put it on this website, and it's there for a couple days, however long. We have inventory, and it is sold at drastic prices. Every morning at 8 a.m., we do send an email to all of our members. So to give you some stats on the size of the operation, we're Alexa ranked 847 in the US. And we have about 20,000 new members per day. We get around 200 orders per minute in at good times. And due to those email blasts in the morning, we see pretty massive traffic spikes. If you look at the graph, and I'll show you one, you'll probably think like Black Friday for the Americans. Or oh, you were just posted on Reddit. Our traffic basically looks like that. That's every day. So what that means is we have to scale our application to sustain that every day, which means we're running on hundreds of servers. And 80% of the time, they're all just chugging along. And only in those 20 minutes every morning, that's when they're getting really busy. Which is also why we're looking into cloud stuff. The technologies we use are Akamai on the edge, and then a pretty standard setup with Nginx, PHP, FPM, APC, and then we use Symfony 2 and Zen Framework 1, as you could probably guess from the title. We use Ember.js on the front end now. and we use MySQL, Solr, and Memcache in the back. I also want to make it clear that our application is actually just the API. And that's what I'm talking about. The Symfony application itself is basically just the API. There is no Twig templates. There is no actual front end. It's all just a JSON. That's the format that we use, and we use helpless JSON. And so we have this API, and then the website or the admin section, both written in Ember, they communicate with it, or the mobile clients, which are iOS and Android. So looking at that, it really seems to be enterprise software. So always, but fear not, I'm not the Java EE guy. I'm not talking about like, okay, well, we need to go through all those requirements documents and design documents, and 10 people have to sign. So what is HAL? How many of you have heard of HAL? Okay, a good bunch. So HAL is basically a very lean hypermedia type. And to give you a quick overview, in HAL, you basically just have JSON objects, and they're plain old JSON objects. But what HAL gives you is a way of expressing links and embed resources, and basically create a standard for that. And so whenever you have a link or embed something, you actually specify the relation, a rel. And that basically follows RFC 5988. If you're curious, that defines a set of, I think, 110 or so rels, like previous, next for pagination, parent, and things like that. But you can also make up your own rels, which is really what you end up doing. And you basically have a rel that looks like a URL. So it would be like www.howitlooked.com/rels/member or /item. And that is to specify relationships. So we have been using helpless JSON before. And so what I want to do is I want to basically compare how it looks like when you do that in Send Framework 1, and then look at exactly the same API endpoint, but how it is implemented in Symfony 2, and kind of what we're doing as well there. By the way, can anyone understand me? Am I talking too fast, too slow, too loud? All right, we're all thumbs up. Sweet. So now this is where we get into a little bit of like code, even though I don't want to bore you and I won't go through it like line by line. But basically, this is how the controller looks like in Send Framework. And as you can see, there is no namespaces, so it's all those nasty, long, underscored names. It's still a traditional model view controller style application. So in our controller, we're basically calling a service, and the service computes some data. And in this case, it actually gets the card for a member. And then it gives us back some result, and we prepare to actually display that. So we need to set like response codes and whatnot. Then we have this service. And in here, we first validate the input. And then we call the model, which I'll show in a second, but that's really just going to run some SQL. And then we need to iterate over those result rows and kind of bring it into a format that we can then pass to the view. So yeah, the model is really not that interesting. It's basically just a select statement. And then we have this view. And what that does, and I don't know how well you can actually read that. Can you? Perfect, that makes the presentation even better. So you basically end up with this long blocks of code that all they do is they need to iterate over those results and then put in rels and to spit out the JSON response. So it's just not good and not very elegant. So here's the issues that we have with Zen framework. This works just fine if you have a small application or your responses are very, very simple. And yeah, then you're fine. But the problem is if you deal with a large-scale application with fairly complex results, this is an absolute nightmare to maintain and work with. And it's really a lot of boilerplate code. And you repeat the same code over and over again, or you iterate over something, and you set the rels, and that's just not cool. The other problem that we found with Zen 1, I'm not saying anything about Zen 2, is that it didn't really scale very well for us. And especially we found that we constantly had to actually override parts of the framework. And that in and of itself is not necessarily a problem, but the way Zen framework is built, it makes it way more difficult to then upgrade later. And we ran into all kinds of issues that way. And so most of the code that we have in our Ascend application is like custom classes by now. And so we have really deviated from the framework. So that kind of brought us to the point where we were like, well, maybe we need to like reevaluate. Zen Framework 2 was not out, and it didn't really look that promising. And Symfony 2 really was pretty much the only choice available at that time. I mean, Laravel is still not out, and I mean, something like CodeIgniter doesn't work for an application of that scale. So I want to talk about a shift in paradigm that I noticed with Symfony and Doctrine as an example in many of the Symfony bundles. And that is actually, in my opinion, also a good reason to switch to Symfony or use Symfony. And that is moving from imperative to declarative programming. And both Symfony and Doctrine, and therefore all the bundles, really seem to embrace this pattern. Yet another thing that they kind of took from Java, because Java loves themselves some annotations and XML configuration files. But that being said, it is a very good way of doing things. So imperative programming is really when you basically just specify step by step your typical PHP code. Whereas declarative programming, it's more about content. So you basically just specify a logic, but you don't have to specify all the steps. So your perfect example is annotations. And to me, annotations are the epitome of declarative programming. I know that people kind of are torn. Some people hate annotations. And I see arguments either way. I think ultimately it's a personal choice. But I do like annotations. So now we're going to revisit the shopping cart. that we looked at in Zend. And I want to point out a couple things that Symfony now allows you to do that make the code way cleaner, and it actually adds a lot of extra functionality. But why did we switch to Symfony? The reasons really were that Symfony gives you this declarative programming, which cuts out a lot of boilerplate code. Whether you use the config files or the annotations, doesn't really matter. Also, Symfony extends way easier, and that's an architectural thing. And that is, everyone who actually had to extend Symfony will tell you it's the best effing thing since sliced bread. And the reason is that in Symfony, pretty much everything has an interface, and you then basically just implement that interface and you register your service. Instead of what you end up in Zend is like you basically have to extend the framework classes, which is just not very elegant and cumbersome. And also, the community is great. I mean, it's all guys like us, and like the IRC channels, and the mailing list, and a very vital ecosystem with bundles. So what are the bundles we use? Really, there shouldn't be any surprises to anyone who's doing kind of what we do. We use the REST bundle, even though we only use small parts of it. And we use the API doc bundle, and I'll get into that in a little while, and the Solarium bundle to deal with Solar. We use the serializer from JMS, which is extremely powerful. Then the HateOS bundle. How many of you have heard of the HateOS bundle? Okay, not very few, so that's probably then good that I'll get into that a little. And finally, we use our own Gearman bundle. I don't know if you're aware of what Gearman is. It's basically a worker queue. And there's bundles out there to deal with it, but we have a very specific use case. And again, this is all like a lot of the customizations we do are due to like the size of our infrastructure. So this is how a controller looks like in Symfony. And the first thing you'll notice is this big block of PHP doc block on top. And you already know I love annotations, so let's go through what those do. First, we have routing and input validation. Remember though, that whole block of code that we needed in Zend, it's all done automatically here. And it's all in one place. Then we actually have documentation. This is extremely powerful if you pass on your API to a consumer if they can get good documentation. And we've all been there. You can have nice documentation written in other documents. The fact of the matter is, it's never in sync with the code. It doesn't have to be in sync this way, but your chances are way higher because it's right there with the code. And it actually uses reflection to build up a lot of the documentation. You'll see that in a minute. So what does the controller do? Pretty much the same thing. It calls a service to get data, and then it creates a response by serializing it. Here, you'll see the service, which really just gets entities from a database, which will run some SQL. And then it needs to convert those entities to view models. Make sense? So how do those view models look like? The view models are really just objects that are value objects. So they basically just have a bunch of parameters. But look at this, look at those annotations that are there. This is a link, and this is how you embed other entities. And what it does here is you basically just specify, oh, use the card items property on that object, and then the serializer will serialize each one of each one of those, and stick them in as embedded resources. The same is true for the links. You just use a regular route and then you can pass in the parameters from your object. I've not shown you all the properties and been used virtual property for computed things. And this is not a talk about the serializer. But what makes this possible is actually the HateOS bundle. The HateOS bundle that I was talking about. That's the magic here. So those links and embedded resources, HAL wants you to basically treat them the same. So HAL basically says, it doesn't matter whether something is just a link or whether it's embedded. You should, as a client, it should matter to you. So for example, you may want to serve out certain resources embedded to a mobile client to cut down on additional requests. Or your result suddenly gets bigger, so you start just giving links instead of the embedded resource. But that's all fine and dandy. But really what HAL and HateOS is all about is URL templates. And URI templates are sexy. What are they? How many of you have seen URI templates? 1, 2, 3, maybe 4, 5? So URI templates are a format to tell a consumer you can change this parameter. So in this case, you actually have to pass in a page request parameter. And you actually can pass in a sort or filter array. But you don't have to. The star means that it's optional. It's like regexes. Why is this cool? It is cool because that's really what fuels HateOS. This is what allows a client to basically go through your application, and you can basically tell your client, here's a URL on how you can get that. And it's, of course, you can always say, well, here's the URL, and you can just append a ID parameter at the end. The problem is now it's convention, and there is no standard, there is no libraries that deal with that. So this is why this is so powerful. And there's other ways of doing it. You can also use forms to do that, but I find forms for simple things like that a little overkill. So that's a standard. There's an RFC, and there's a bundle for that as well. And that bundle is basically just a Symfony router where you pass in those values and it gives you back the formatted URL. And the way it looks like is like any other route. That's just a service. And of course, it now actually integrates with the HateOS bundle. So say you have this defined as a route for an image, then you can actually now have application in your source to be, and it'll actually use the templated router. And as you can tell, that kind of stuff gets me excited. So I think I mentioned it before, but HAL and HateOS really are two things. They're a format, some like media type, but then there's kind of a philosophy behind it. So the philosophy is here that you have links and embedding, and you have documentation. A HAL API is basically self-discoverable. All you have to do is basically give some first entry endpoint, and anywhere they should be able to get to should actually be part of a link somewhere. And then all your standard HTTP operations apply on top of that. So use get, put, post, delete, and patch if you want to make it all work. And that, together with the documentation, should pretty much allow anyone to implement a client. So remember the annotation I showed you earlier for the Nelmia API doc? This is what it actually generates you. You can actually get a fully browsable HTML documentation of your API. And yay, we are RESTful. That's actually level 2 in Richardson's maturity level, just by having the resources and the HTTP verbs. One thing I want to point out here is, why do we have a form here? That seems a little odd and kind of exactly like counterintuitive to what I just told you about. Oh, we don't have any twig templates. That form is actually a twig template, to be honest. So why do we have a form? The reason is very simple. Because we can't basically get it for free. We use the Symfony form component to validate and transform our input data from the posts and the puts to models. So why not write the other 4 lines of code to just generate an HTML form? It doesn't have to be pretty. It's not to be used by an actual customer, but it makes testing very easy, and why not? If you then go onto an endpoint, this is how it can look like with very little work. This is basically just a markdown block, and everything else is actually done with introspection. And you can say like, oh, actually I'm passing in this form, and it'll populate it automatically and give you the types and whatnot. So if you haven't used that bundle, definitely give that a try. So next I want to talk a little bit about performance and how to measure performance, because that is, it should be important to anyone, but especially if you deal with those like large traffic spikes, measuring performance is of like utmost importance. And one thing I want to kind of talk about it a little bit is like, why is measuring performance so difficult when you deal with declarative programming? Well, think of it this way. If you do imperative programming, it's pretty easy to measure performance. You have your source code, and all you do is you sprinkle that source code with either you get the time in milliseconds and just subtract them. That's the poor man's very easy way. Or you put like some sensors in there, use the Symfony stopwatch, or use Xdebug. And that works very easily. But where do you measure here? We have annotations. It's like, or you have config files. How do you find out where the slowness comes from? What you need to optimize? The answer is, there is tools to do that. One we use is a tool called XHProf. It's a hierarchical function level profiler, which sounds very frightening, and I don't want to look at the source code for it, but it's actually a very powerful tool, and it's very, very easy to set up. It's basically just a PHP extension, and it's written by Facebook. And they definitely have performance on their mind, and it also means it scales very well. The way we use XHProf is actually with a tool called XHGUI. And XHGUI is basically just sitting on top of XHProf, and it does a couple of things. Number one, it actually uses a shared database backend. And we use MySQL, but I think the latest versions now actually use MongoDB. And what does that mean? What does the shared database backend give you? Well, first of all, it means that all your performance data you have in one central location. It also means you can easily query and aggregate and do all kinds of funky things with it. It also means you can actually pretty much run performance data on your production environment. You may not want to run it for every single request, but you can easily set it up with a load factor of, say, 100, where then basically just every 100th request randomly, of course, you actually get performance data. And the overhead is not very big, so to the customer it's not really noticeable. And of course, there's a bundle for well. So what does it look like? XHGUI gives you this interface, and basically you have this piece where it should just be your worst offenders. This is for one specific request. That oftentimes gives you a pretty good idea of where to look. And you can like click on them and it'll actually show you what it is. But it also gives you this overview of every single function that was called, hierarchical. And it gives you the number it was called, the CPU it used, the memory, and you can sort it, and you can actually drill down. You can actually say like, oh, okay, well, here's like the JMS serializer took 30 milliseconds. Let me look into that, and you click on the serialize function, and you get like the same thing, but now just for this serialize function. So this is extremely powerful for tweaking performance and finding your bottlenecks. And it's actually very surprising what you find. You need to be a little careful though, because especially if you run it in like dev mode, a large chunk here will just be auto-loading and things like that. So you need to be, a little careful there to get good results. The other cool thing is that XHGUI aggregates data. So you can actually say like, oh, okay, well, I'm actually less interested in like how long did it take to load up member XYZ. What you're really interested in is like, how long does it load? How long does it take to load up any member? So what XHGUI will do is it'll actually like aggregate your performance data and basically take out those parameters. And then you can basically see like, oh, okay, well, here's my 95th percentile. Also, since it has all those like data, it can also generate call graphs for you. And that's what they look like. This is a typical API request. And you see it's like there's a lot going on. So I don't know if that is truly helpful to anyone, but I think it still looks cool. And if you print them on like a big plotter, they're pretty cool to hang on your cubicle. So what are the lessons learned here? Number one, what we found is large-scale Symfony deployments are not simple. And that's why you see tweets from us that are like that. And you see like FatPod tweeted it. That's kind of cool, but what's the problem? The problem is that most people that use Symfony deploy Symfony to 5 servers, maybe 10. We're deploying to hundreds of servers. And while the tools are still the same, and while you can still use the same tools, some things just don't scale that well. As an example, take Capistrano. Capistrano is a phenomenal tool to deploy code. And it can easily deal with multiple servers, no problem. That's fine if you have 5 servers or 10 servers. If you deploy your code to, say, 500 servers, do you want to run Composer update on each one of them or Composer install? Probably not. It's just slow and wasteful. And so there's all those weird things that we ran into and are still running into occasionally, where there's really no good solution that someone published about. There's also always problems with things like APC and things like that, where people are always like, well, why don't you just hop your server? Yeah, that's easy if you have 2 servers and no customer that's like on there right now, and no, like you can do it at night when there's no traffic. So there's some of those problems. What we found in that respect is there's just not much documentation. If you find someone who has run into that problem, they may share their solution, and there are solutions, but really there's not much documentation. We also found that while the actual Symfony components are absolutely phenomenal, they are hands down the best component now in the PHP sphere. But there's all those components and modules that you need with like large-scale applications that the framework doesn't provide. And it doesn't have to. I'm not complaining. I'm just saying this is a problem you run into. And it's just some of those Symfony components, they're just not made for that kind of scale. You can easily adapt them. So as an example, for example, we need session storage that uses multiple layers. So we want to use memcache and a database. And Symfony doesn't do that out of the box. That can't. You can use memcache or you can use the database, but you can't use both. And so there's a bundle for that now as well. It's basically just a chain where you can define, say like, oh, well, I actually want to write to all my layers, but I want to read in a particular order and only keep reading if I don't find it. I want to first try memcache. If the session is stored there, let's just read it there. Otherwise, go to the database, we know for sure it's there. So really, we need more documentation and community around enterprise level Symfony development. But lastly, one of the main things we learned is our developers really love Symfony. Like all developers that have worked on a project, they don't want to switch away. They just love it. And that, I think, speaks for itself. So, if you're running a large-scale Symfony application, come talk to me. I think there should be some more exchange about the big players. We tried to talk to YouPorn, for example, because they are probably the biggest Symfony to install currently in the world. But of course they don't talk to us, or they're too busy. But what I believe is we need kind of a forum for larger scale enterprise Symfony applications. And it's just an exchange of ideas and kind of solutions, because we don't want to reinvent the wheel all the time. So, hit me up. So, thank you all for your time and attention, and thank you, Symfony community.
What's the best way to get you up?
Twitter, or I can give you my email. We can talk. So, and let's connect on GitHub, Twitter. And please rate it on joined. Last night the link was not there yet, so. But if you go to the Symfony Portland joined page, it'll be there. And we always love feedback. Any questions? Yeah. Mm-hmm. Yeah. Mm-hmm. Mm-hmm. No, there is no automated way to do that. What we ended up doing is, because we actually have a similar problem, we actually have session roaming from the old send application, because there's still quite a few endpoints that still are in the send application, and some of them are in the Symfony application. We actually have a bridge, so your session actually roams with you no matter which application you're using or your front end is calling. But that's a lot of custom code and like custom session hacking and magic and like pulling out values out here and stuffing it back in here. It's not pretty, but if you want, I can definitely kind of maybe share some of that with you. Maybe that gets you started. But yeah, thanks. Yeah?
You're saying that the Scrum doesn't scale to 20 servers. Did I miss something?
Oh, that was just an example. We actually are not using Capistrano. We actually use very custom scripts, which is also because we basically also have the send application, and they're still kind of tied together. So we have custom shell scripts, and basically we basically first build the application and then just rsync it to all the servers. Which, yeah, I guess you could.
Just for your information, I actually do a website and
Mm-hmm.
we have a Symfony that we actually finish by simply application
Mm-hmm.
that way you can actually play with the servers
Right. Yeah, I mean that's basically what we do with rsync. It's also basically then just pushing it out all at once to all servers. But yeah, thanks. That's another interesting way of doing it. Yeah. Yeah, I have. At the same time, there's also power slightly slower in a way. I say that. One of the things that happened with Send is we didn't use Send's ORM because it was just POS. We are using Doctrine. So, of course, if you look at aspects of the application, it is slower because you have an ORM sitting around and it's not all like hand-coded SQL, super highly optimized with the order of the parameters. But that's kind of a trade-off. We still have a, just to give you an idea, we still have a kind of performance goal of 200 milliseconds per request. And for the most part, we were able to achieve that with Symfony. Whereas with Zen, that's, yeah, it's Zen. No, we started doing that, but then decided, oh, well, if we're really switching to Symfony anyway, then why bother? And yeah, and like even getting it all hooked up with all the auto-loading craziness is annoying. So. Any other questions? Yes. Basically what they say is everything under a second is good. Everything over a second starts feeling sluggish. That's why we were like, well, let's push it a little and not say like, well, you need to be under a second, let's say 200 milliseconds. Because you still have all the like the front-end code, the Ember application still needs to actually unmarshal the data and change the view and whatnot. So you still lose some time there. And it's always good to kind of have very strict requirements, and then kind of, if you have to loosen them up a little later, then that's fine. But I mean, let's shoot for the stars here. So, but there's no like, we just came up with that number. So like, well, why don't we try this? Which, I mean, of course, if you use Akamai, anything that's cached, you easily get that. But it's for the actual responses that come from the server. But yeah, good question. Yeah. Yeah. The the Symfony application itself is actually still running on PHP 5.3 because they're running on the same server in parallel. So, yeah, I would assume that. Excuse me a second. Right, it was running on 5.2 and now it's running on 5.3. That was actually not connected. So we were actually already using 5.3, a slightly older version of 5.3, and then we upgraded. We definitely do want to upgrade to 5.4 for performance reasons. But Zen does actually not like that because there's some, or our code has some backwards incompatibilities with SF4. So. Other questions? Yeah.
What was the approach that you took in replacing Zen components? Was it a complete replacement overriding, or did you slowly introduce new things over time? Or, it sounds like there's still Zen components in your stack somewhere. So were those like low priority items or non-mission critical type things?
Well, there's no, actually, the things that are still Zen and that will stay Zen for quite a while are actually very critical parts. That's actually the reason why they stay in Zen, because they're also pretty gnarly and big components. For example, like a checkout. Yeah, that's way more difficult to move over. Other than that, I mean, we basically just started, and you can basically just replace bits and pieces. The beauty of using HAL here, and I'm cutting back here, is you actually don't even need to change your clients. All you do is you change a link, and you change the link that was served by the Zen framework to a link that's now served by the Symfony application. As long as your format stays the same, you're golden. So, yeah. Yeah. No, all the custom code is by now merged into the HateOS bundle. No, the HateOS bundle basically provides you with links and embedded. If you want HAL, you actually need to just configure it in a certain way to get like the keys, like the underscore links and underscore embedded. But other than that, yeah, the HateOS bundle now provides all of that. Well, then thank you.